Well, welcome team. I want to take the next few minutes here to kind of talk a little bit about our Rhino Turn product line, our Gold Rhino. And I'm excited to share this product line with you, as it's one of my favorites in all of the ISO Turn line. And so the Rhino Factor here, when we started this line, we were kind of looking at the industry, and the automotive industry was a primary one, but we don't have to just exclude it to the automotive. It's for any industry. But what we realize is near net shape parts are becoming more common, especially in the castings or forging, and then 3D printing is another big one. And so as the near net shapes are more common, and we notice a lot of the turning depths of cut, so about 75% of all the turning applications out there have an 1/8 inch or less depth of cut. And so this was our mindset with the Rhino idea there. So when we looked at the ISO size, these are the traditional ISO sizes coming up here, and this is kind of what I consider the 1/2 inch size there. And we compare that to the 3 inch. Now, sorry, 3 inch, the 3/8. But now when I say the 1/2 inch, so this is traditionally the CNMG 4s, but the T's and the V's, these are 3/8 size. And so we kind of asked ourselves, is the 1/2 inch size for only an 1/8 inch depth of cut needed? Do we need that big of piece of carbide for that? So we looked at what I consider the 3/8 IC ISO turn. And we go down here to 3/8, and now the T and the V, they go down to 1/4 inch, and that's 5/16 IC. But so just as I'm using these as a general term to the IC. Well, the problem was with the 3/8 is that the 3/8 IC there, they didn't perform as well. Okay, so the 1/2 inch IC still had the best performance, and also I'm going to say the best chip breaking. A lot of times when you get to near net shape parts and some bevels on there, it's hard to break the chips. So we just had a lot more offering in the 1/2 inch, so most everybody used the 1/2 inch IC. And so this kind of what developed is, how can we make this better? And so in the Rhino turn, the first thing we did go down to the 3/8 IC. Okay, and then this was one crucial area. It was that we kept the thickness the same as the 1/2 inch IC. So the thickness is a real importance in the performance of that. And then another thing we did is that we had a trumpeted hole. So we didn't use the traditional straight hole, as you can see here on the ISO turn. We used the trumpeted hole, and that had a lot to do with another product line that we had was called the Gold Duty. And we used H-type holders. And these H-type holders, they provided pull back force, kind of like the lever lock, but also top down. So it would bring the force down as well. And so these were a nice strong holder in there. And most of our customers love that no top clamp on the top. And so when we launched the line, that's the holder. That was our first holder choice. And we since expanded it to top clamp holders as well. And we can get into that in another section. But so these were the three primary factors of what changed the Rhino. And with that Rhino, now we have what I consider the Gold Rhino size, which is our 3/8 in the category there. And as they're coming up here, you can see, so now the 3 here, it's 3/8, but the thickness is a little bit thicker on the D size, and we can talk a little bit more about these, but it's not a 3/8, this one's a 7/16, but the S is a 3/8 on there, and the T is actually 5/16. But this is what came out, and our performance was better. So the main focus here is it's a smaller carbide insert, and then we need to have performance. So price and performance is the advantage of the Rhino there. Okay, so and that's our main focus with this product line, is the price and the performance in there. And we're going to talk a little bit more about why the performance is and the price in a little more detail. But this should be the two main areas when you think of Rhino. Any of our Rhino lines that you hear the word, it's economy. Okay, it's a price solution, but we don't sacrifice performance to get there. So looking at the pricing a little bit, now I'm just going to show list price here. Okay, if I'm just comparing it to our list price of the CNMG 1/2 inch, the 432 to the 332, we can see that's a 24% savings just on the list. Now, and another thing that we're comparing this price to our price. Okay, so this is our own 1/2 inch, and we also know that other competitors out there, sometimes their prices are a little higher than ours, so it gives us a little more advantage. But we'll see that in some case studies. We also got a peripheral ground. Okay, so peripheral ground, we get a nice 20% price advantage. And then on the SNMG, okay, very similar to the C's, we get 25%. The TnMGs, we get a nice 24. Now the DNMGs, we don't get a nice, not as nice as the C's, but it's still a 10%. Okay, so you walk up to your customer, they're using the 432. It's nice that, hey, here's just our Gold Rhino can be a nice 10% price in there. So getting back to the D and GG, so there's our peripheral ground. We actually see a little bit better on there for that one, but still 11%. And then we get to the W. Okay, so the W is a nice 22%. And then the V, this is the big one here. The V has a nice 28% there, and then a 23% on the ground. And very good. And that's one thing, I know the 28% here, that's a nice savings. But when we, and again, this is list price, but you're looking at $6 here difference. And so again, the pricing is a good advantage to look at. And for whatever reason, the V is going to give us a really nice price savings. Okay, I want to continue on a little bit. We know that it's a nice price savings, and we want to get to the performance a little bit here, and kind of why these are performing, these sizes are performing. So I know some of you, including myself, been around for 20, 30 years in the industry, that the CNMG 332 size here, it's not brand new. It's newer in the last few years, but I believe Valinite was one of the companies that had this size as well. But their issue was the performance was not as good. The 332 in their size, they still could not get the performance out of the same as the 432. And I want to talk about why. So the first thing here, obviously, is the thickness the same. So that's one general reason. And here's the reason why I think the Valinite ones didn't perform as well. So with the thickness the same, you obviously are a little closer to a cube shape. So I think the insert is in the pocket a little bit more rigid. And then here's the big one that we did. The geometry of the 4 we kept as the same as the 3. So in general terms, whenever somebody is creating a different IC size insert, so whether we go from a 1/2 inch size to a 1 inch, usually the geometry grows or shrinks. And so that was the issue on the 3/8 IC size here. Not only the thickness here, but the geometry shrunk down a little bit over here. And so the edge prep is not identical. The chip breaker rake angles were slightly different. And we'll see that in some of these inserts that I have. But to me, this is one of the biggest factors of why the Rhino performance is not only just as good, it's generally just as good, but a lot of times we're seeing better performance than the 4. So not only you have a pricing advantage, but the performance is going to be a little bit better. We should expect it to be a little bit better. Always the same. And so then another area I want to highlight, we'll go down here at the bottom left here, the V shape and the W. So we traditionally had these two sizes. Okay, this was 2.5, 3, which is 5/16, and this is the 3/8 IC. And so notice how the sizes are the same. Now, we didn't come out with these in the initial offering of the Rhino. So these were added later because people just started really loving the Rhino concept, and they asked, can we have the V and the W that can take the H-type holders as well? And so that's why we created these. So that's why these will have an X and an X in them, because they're different than our traditional standard ISO. And one thing we did different, so we also added some surface area. And so we just didn't want to make the same the same insert and increase the offer. We increase the seating surface here around this blue area over 2 times compared to the traditional WNMG 3. This is the 3.3 size. So you can kind of see, so this also aids into holding it in the pocket better. And then if you look at the chip breaker here, look at the edge prep a little bit, but look at these little pads or bosses on the insert. Look how small they are compared to the WNMX. So this is where I'm getting at for the chip breaking and the performance. We kept that edge prep the same. So even though down here we have the same size, the performance still was not as good. So I would encourage anybody, if you have customers that are currently using our VNMG or WNMG, and if you want a better performance insert, we can change to the Rhino. Now, obviously, I'm going to talk a little bit about the holder issue, but the Rhino, it does take, since that hole is bigger, this trumpeted hole here is a little bit bigger, it does take a unique H-type holder. So we do have to cross over the holders, and I also know that's one of the biggest bottlenecks for this line, trying to convince your customer to change out the holder, especially if they got 10 machines, they've got the ISO 432 holder, and now we come in here with this insert, and yeah, we've got to replace the holder. So I know that's a hurdle, and hopefully we can get through that first through price and performance. But so with the V&W, we've got these 2 sizes, and I know I get a lot of questions on them about, can the VNMX fit in the VNMG holder? And the short answer is no, it will fit in there, but the clamping is not going to be the same. It might do if you're doing a small depth of cut, but it's not going to be the same. So we want to try to push the Rhino here with these X's in there because the performance is better, even though the pricing is the same between these two. And then also our product breadth is so much more. You got so many more options. This is what we expanded on. All right, so just to go over a couple of case studies here. So here's one. This one is actually an older one, but it's up in Canada area. A25 steel here. We got the application parameters. We're going against a CNMG 432 insert. We went with our Rhino size, and we're competing against here. Okay, so the against our 8125, so similar grade, similar breaker there. Actually, our MT is a little bit more aggressive, not much, but a little bit more. But you can see our parts per edge. We went from 15 to 21. We had a great increase in the tool life there. And then the cost of the inserts. We all know that usually runs a little bit higher price. So now this is where we're going to really start seeing the gains of the price. It's at least 20 to 24% here with a C, but now that the competitor insert is even higher, so we're seeing a 51% cost reduction. And then we went from a cost per piece to 20 cents to 7 cents just for the insert cost in this application. So a huge win here for us. Now, the other thing that gets a little unnoticed here with these is that sometimes that we increase the tool life, so I can come over here to my parameters and increase the productivity and get a further gain through productivity as far as for the cost per piece of the application. So next one here, this was a test done out of Minnesota area, 17.4 stainless. They're going 1450. It's the stainless is the softer one, but 450 surface footage. Again, lighter depths of cut, 55 thou depth of cut in 14. So it's a near net shaped part. You're getting the small depth of cut, but higher feed rates to rough it out. We're doing your 432 insert with our Rhino, and we're competing against our 9225. And look at the tool life gain here from 34 to 64, almost a double, almost 100% increase. But with fairness there a little bit, we did have a little bit more wear resistant grade than the, and that would actually be a little more wear resistant, but we're right in the middle there. So a nice, great performance increase here, tool life increase. And then again, in that area, had kind of a higher price, so we've seen a 42.5% cost reduction just from the insert itself. And then the last application example case study here.
Yeah, this application was unique. Specifically, what they were running prior to us studying the process. They started out running these components, a family of parts ranging from 4 inches overall length all the way up to 20 inches overall length. And they were using positive inserts. And as you can see, they were running they didn't have any major complaints other than showing us the application and trying to find a solution to eliminate breakage. That was one of their challenges prior to us looking at it. And after studying the process, reviewing everything, looking at their programs, watching every tool path very closely, we were able to narrow down exactly what was going on at every work center. They had about 22 machines total. So the solution that we were able to come up with was first do an apples to apples comparison with our product. They were not familiar with the Ingersoll turning line at all, so we had to do a nice little introduction with our lines and our chip breakers and our grades. So they requested an apples to apples performance. So we matched what they were doing with no program modifications at all. So moving forward, we observed a couple things in the shop. And one, as you can see, is C4 capital holders is one of their holder types. And we saw a 5-gallon bucket full of C4 capital holders. And they were, not packaged, sitting on top of each other. So we had to ask. And their response was the capital holders were part of their usage due to the breakage. They were damaging the pockets. So after we had learned that, we proposed Gold Rhino and brought a sample capital holder of ours in to offer obviously 2 more cutting edges and a little more robust system. So after we were able to propose the 8105 in the PC, and the PC is very similar to the PM, not exact, but very similar. We couldn't apply too much or too less tool pressure because of some of the distances between centers. So as you can see, the result was very, very positive after proposing Gold Rhino and asking for some flexibility to modify programs. We modified the programs prior to running our tool and asked for a 20 to 23 degree entry angle on the stock removal between centers. After we had applied that method, as you can see, the tool life spiked up substantially. And eventually, now that it's been 3 years running this product, we have had zero breakage zero tool life usage caused by breakage. So if they're changing a tool holder, it's primarily personnel related. So this has been a very big win for us. They've been running the product for 3 years now, and the result is still very positive. We're optimizing as needed and as we can, every month. So we were able to offer them this insert thing and basically offer 2 free cutting edges. The price was a wash compared to what they were using since they were getting special pricing. However, we were able to offer 2 free cutting edges. So this was a pretty big win for everybody, all sides of the spectrum. So they were pleased with the overall changes we requested in the programming, and we applied this across the board. There were other types of materials that aren't shown on this presentation, only 2 more, specifically 416 and 4140. So with all that being said, we applied this methodology across the board and pretty much saw this type of increase in tool life everywhere.
Awesome. Thanks, Rich. And just a couple things I want to point out here is, we get used to looking at the Rhino inserts from on a negative, C and MG or D and MG, but we also can look at some positive inserts here to try to apply the gold Rhino, depending on how, if it's a roughing or whatever, and to get more cutting edges. So this was a great example of here. Yeah, it's a positive insert, and then we apply the Rhino in there to get the 2 extra free cutting edges here. And this savings just shows the one material, the 4150V, and this is an estimated 15,000 barrels a month. But the other 2 materials Rich mentioned was the 416 and 4140, and they also do 10 to 20,000 maybe of those as well. So, and they put this insert on all across the machines there. So again, and thank you for everybody's time here. Again, I didn't want to show all of our product line, and maybe we'll do another Rhino turn to kind of show you some in-depth holders and what's new